We're going on now to topic 5.4, applications involving the quadratic equation. So we'll do one in dealing with solving problems, which is number 1, and then some examples in solving formulas. So the protocol for doing this is we're going to read it over very carefully and see what we come up with in terms of a formula. So Horace drove his car 240 miles at a certain average speed. Now, had he averaged 20 miles per hour more, the trip would have taken 1 hour less. Find Horace's average speed. Now, the first time I read this, I had to read it again and again. And then I thought, well, what formula could I use? Well, one that we've used quite a bit is the distance formula. Distance equals rate times time. So we have distance here. We have a rate that we don't know, and then if we went faster, it would be a different rate in a sense. And we know if we went faster, it would take 1 hour less. So after thinking about this, I thought, if we could end up with an equation of time equals time, get these two to equal each other, then we could solve it. So I had to solve this equation for t. So I'm going to divide both sides by r. Now on this side, the r's cancel out, and t is equal to distance divided by rate. So here, if we had distance divided by rate, somehow distance divided by rate, this distance divided by rate is time, and this is time. We want to get our times to equal each other. So we can go over here maybe, and let's set up what we can here. And I want you to copy this in your booklets. Now we know the total distance. That stays the same. This is 240, and this is 240. And we know the average rate we can call r. So distance divided by rate, this is some sort of time. Now we know on this side it's going to be this rate plus 20. So this is time and this is time, but they don't equal each other yet, because this is faster. Let's say if this were 4 hours and this were 1 hour less, this time would be 3 hours here. So what do we need to do to this representation of time, which is 4 hours, and this representation of time, which is actually 3 hours, to make these equal to each other? Well, remember, this side took 1 hour less. That's what made it 3 hours. So to make 4 hours equal 4 hours, we have to add 1 hour of time there. So I cleaned it up a little bit. I'm keeping this as my basic reference. This is now time, and this is equal in time. So I have a rational equation, that is with fractions. What do I do to get rid of my fractions? Well, I have to multiply each term by the common denominator, which is going to be r, and r plus 20. That is this fraction and this fraction. So let's clear parentheses now. This r will cancel out, this r will cancel out, and I'll write it down here. So I get 240r, this r times the 240, and then 20 times 240 is 4,800. And this is one term, and this is one term. So now I'm going to cancel this out with this, and I'm just left with an r, 240r. And then I have 1 times this, so this then becomes r squared, just multiplying these together, plus 20r. So I've cleared fractions, and this is what I have. Now I have a quadratic equation. In order to solve quadratic equations, I need to put it in standard form. So the next thing I'm going to do is subtract 240r from this side and 240r from this side, and they just disappear. And now what I'm going to do is transpose this to the other side, so I now have a 0 on this side, and I'm transposing that, it just changes its sign. Now I could use completing the square, I could use factoring, if it would factor, and I could use the quadratic formula. Well, interestingly, and again I worked with this already, this factors. So r there, and as I played with this, I saw that this 48 is 6 times 8 is 48. So if I had a 60 and an 80, this would give me that, and the difference of these two would be 20. Ah, this is plus, so my larger one needs to be positive, and this one negative. So solving this for finding the zeros, I get r equals 60, or r equals a negative 80. Well, you can't have a rate of negative 80, so this is an extraneous root, and my r turns out to be 60. And this r is 60 also. So 240 divided by 60 is 4. Remember, this is time. And this is 240 divided by 80. This is 3. Plus this one that we added is 4. 4 equals 4. And his average speed is 60. It checks out. So there's the first one. It took me just under 10 minutes to show you the thinking. My initial attempt at doing this took longer because I had to figure out what I was going to do. But many of the problems you're going to get in MATLAB will be built around this model here. Okay, let's go on to solving for some letters, and in this case we want to solve for the letter G. Now notice G here is under the radical sign. So, as we do, we want to isolate the term we're looking for. So we need to get rid of 2 pi. Well, we do so by dividing it out. What we do to one side, we do to the other side. So here these just cancel out, and I'm left with this. And to save a little room, we'll just erase that. Now, a technique that we've worked on, how do we get rid of a radical sign? Well, if the index number is 2, we just raise it to that index number. That is, we square both sides. Now, when we square this, and I'll put it down here, we get t squared, and we square that. That's going to be 4 pi squared equals L over G. This just, when we square this, it just becomes the radicand. And a technique we had earlier, running out of room, we're going to just cross multiply. So we get t squared G equals 4 pi squared L. Just cross multiplying. We had that in an earlier section. Now we want to solve for G. We just divide out the t squared. And these cancel out. And there's our answer. G equals this. Okay, going on to letter B, and I'll write this out a little bigger for you. And I'm also going to put it in standard form, because this is not quite standard form, and you'll see why I do that in a few moments. So I get 16 t squared plus, this is initial velocity of t, minus s equals 0. Now, this is in standard form of the quadratic equation, and we want to solve for t. Well, for this one, we have to use the quadratic formula. In order to do so, we need to find out what is A, what is B, and what is C. And now we start substituting. T equals a negative B plus or minus the square root. Now, B is V sub O, or initial velocity. To keep that so we square it, we have to put it in a parentheses. And then minus 4, which is in the formula. A, which we said was 16. And C, which we said was negative S. All over 2a. So 2 times 16 is 32. Now we're almost there. We just need to do a little work here. So this then becomes t equals negative v sub o, which is initial velocity, plus or minus the square root of our initial velocity squared. Now we have to put that in parentheses, because otherwise we would just think this sub O is squared. It's this quantity squared. Now a minus times a minus is going to make this plus, and 4 times 16 is 64s all over 32. And that's the answer they have down below, and that's how we got it. So anytime you see something like this where, how would you ever find t? Well, identify A, B, and C and put it in the quadratic formula. And I did get a hint by looking at the answers, what they wanted. All right, let's go on to the last one now. This one is, I'll write it big up here, W equals the square root of 1 over LC. Again, we want to get rid of the radical sign, so all we have to do is square both sides. So we then get W squared equals 1 over LC. Again, taking this index number and raising it to that power, then it just becomes the radicand. Now, in a sense, this is over 1, so we can cross multiply here. W squared LC equals 1. And we want to solve for C, so we just divide out what we don't want. And we end up with C equals 1 over W squared L. And you'll notice they have it written LW squared, but that's not a problem. This is good. Okay, we are going to do a few other little exercises to give you some more practice, but this will wrap this up.